channel Conceptual Learning in Physics. Once again, in this lesson number 14, I am taking a problem related to conservation of angular momentum in mechanics in physics. Now the question is, a solid sphere of mass m and radius r is rotating about z dash axis, passing through its CGG with angular velocity omega as shown in the figure. Find and change in angular velocity omega of this sphere if a point mass m is attached at top point A. Now in this original case, the moment of inertia of the sphere about the axis of rotation or axis z dash will be given by I z is equal to 2 by 5 m r square, mass m, radius r. Now the angular momentum is L. Now the angular momentum is given by L and the angular velocity is omega. So angular momentum in this case is equal to L 2 by 5 m r square omega, since L बराबर I into omega. Since prior to the mass attached, the sphere was having its angular momentum conserved. So like after the attachment of the mass at point A. So in both the cases, the angular momentum of the sphere or system will be conserved because there is no any application of any external torque on this system or sphere. So in second case, in this case, we are required to find out the moment of inertia of this system about z dash axis. Since the mass m has negligible dimensions, therefore the moment of inertia of this point mass m about its own axis passing through its CG will be equal to 0. And so the distance d between the axis of rotation and z dash axis of both the point mass and the sphere is 0. So d बराबर 0. So moment of inertia of a sphere and point mass I1 is equal to I sphere plus I point mass. This is equal to 2 by 5 mr square plus m into d square, where d is the distance between z dash and vertical axis passing through the CG, that is G. Plus I point mass m into this distance is m into its dimension r, r square it is also about z dash, it is also about z dash, plus m into d square. Since r बराबर 0, dimension of point mass, therefore the moment of inertia of point mass about its axis will be 0, and the distance between its between the vertical through its centroid and z axis d is also 0. Therefore the I1 will be equal to 2 by 5 mr square plus 0 plus again 0 plus 0 is equal to 2 by 5 mr square. So I1 is equal to I, therefore omega is equal, omega 1 is equal to omega answer as L बराबर 2 by 5 mr square, omega is equal to 2 by 5 m r square omega 1. Omega 1 is equal to omega, that is the answer. Okay.